you very much for taking time. I think I'm up against Venkat, so his probably waiting room only over there, or standing room only. So I appreciate you coming to my talk. A little bit about me. My name is Deandrea. I'm a developer advocate at Red Hat. Although I do technically have the t-shirt to say I helped build Quarkus, I'm not an engineer on the Quarkus project. I do contribute to it here and there. My background, I have a very heavy background in Spring, which kind of is why I put this talk together. I don't know about anybody else, but whenever I learn something new, it's always compare and contrast to things that you already know. And hey, does this do it better? Does this do it worse? What are the differences? What are the similarities? So as I started learning Quarkus when it came out in late 2019, I was obviously comparing and contrasting, and it took me a long time to get on the bandwagon. But the more I play with it and the more I do with it, the more I really tend to like it. Hands in the air. Everybody knows about Spring and has used Spring in production. Yeah, that's what I figured. Anybody running Quarkus in production? Dilly-dallying with it? Play with it on your laptop? Know how to spell it? Yeah. All right, excellent. So let's get started. So right after this talk, I actually wrote a book about it. Learning Quarkus from the concepts of Spring, and I wrote a book about it. We're going to do a free book giveaway at the Red Hat booth right after this. That being said, there's a limited number of copies. So unfortunately, although it's free, not everybody's going to be a winner. But it's always free to download, free to read. I don't make any money on it, so as much shameless self-plugging as I want to do, I don't make a dime off of it. So it's pretty much for your enjoyment. So let's take a little history lesson. Who can tell me how old is Java? 1995. So let's do the math. So it's going to be about, what, 28 years old? Is my math right? 28 years old? Is Java older than anybody in here? Yeah, don't be afraid. Raise your hand. Has anybody been using Java since the beginning? Nobody. One hand in the back, couple hands in the back. I started in 1997 with Java 1.1. I went right from Swing. Anybody ever do Swing programming? And I skipped Java EE completely, and I went right to Spring from there. So the whole Jakarta Java EE thing is just way over my head. But that being said, the ecosystem around Java is really what can't be beat, right? Because there's so much stuff, there's so much tooling, frameworks, IDE support, libraries. I mean, you name it. There's a huge amount of support, which is why organizations have started to adopt, or not started to, but have adopted it over the last 20 some odd years. It's tens of millions of developers, multi-billion-dollar industries are running their enterprises on Java. But it was really invented before cloud, Kubernetes, all these things that we're doing today were around. The ultimate thing that Java was invented for was the write once, hum a little bit, the write once, run anywhere problem, right? I want to be able to write my application once, not have to worry about where it's going to go, whether it's going to be Linux, AIX, Unix, whatever, so that I could just write it once and run it anywhere, which we'll kind of come back to that because technology tends to be cyclic. And what are we doing now with native images? We're compiling to a platform-specific runtime, right? So we'll kind of circle back to that. But with everything else in computer science, there's trade-offs. There's no perfect answer to any particular question. It's knowing what the trade-offs are and what makes the most sense given the trade-offs. So what were the side effects or the trade-offs with Java? You got this really highly dynamic runtime, which does a lot of late binding, because the code is not compiled to the machine-specific language. There's a whole bunch of interpretation and bytecode and whatnot that happens when the application starts. So it's highly, highly dynamic that does all kinds of late binding and initialization. So as anybody who's been around for a while, do you remember the days where you were running Eclipse, you were running Outlook or Lotus Notes, and then pick your app server of choice, WebLogic, WebSphere, whatever it was, but you can only do two of them. Pick two of the three because you can only ever do it. And then you just start a compilation and deploy. It's like, oh crap, I forgot one thing. And it's like, I may as well go take a bathroom break, go talk to the folks at the water cooler because it's going to be 10, 15 minutes before I can actually recompile my change again. I see lots of people laughing. So you're with me. Or what about how often were you doing releases? How often were you putting code into production? Twice a year? Once a quarter, every fifth Tuesday when the moon aligns and is in a half moon and the tide is high, and whatnot. So, and how often did you upgrade the JVM? Please nobody say you're still running Java 1.6 here. No, nobody's running Java 1.6. Java 8, is anybody still running Java 8? Yeah. So, like you say, history is cyclic and it repeats itself, but people were not doing these upgrades every now and then. And so how did you scale your application? Your application was slow. How did you scale it? I'm just gonna throw a bigger box at it, right? I'm gonna get a bigger Sun Spark with more memory, more CPU, and I'm gonna run my application, and it runs faster. Although in one of my applications that I was working on, we threw bigger hardware at it, and it actually slowed the application down because the box had a huge amount of memory, but only a certain small number of cores, and the CPU speed was really slow, and our application was very CPU intensive, so it actually slowed the application to a crawl. We spent like $10,000 on these new Sun Spark things and plugged them in, and what, it's slower? So, but then things started to change, right? How often was J2SE and Java EE doing releases? 3 years, 5 years? You know, that's like an eternity in today's standards. And so what happens within communities and open source and whatnot when things are slow or don't go the way people want to? They band together and do something different, right? They form things. So that's where things like microprofile and Spring Boot and whatnot all came from. And what did they do? They helped to make Java even more rich and more features, because now developers have like all this choice. I can do Java EE, I can do Spring, I can do microprofile, I can do Micronaut, I can do Quarkus. I got all these different options, and sometimes it's like overwhelming. Well, what's the best use case and what's the best technology for what I want to do? But at the same, maybe not at exactly the same time, but kind of in the same time frame, the organization of the development team started to change. You know, agile, we gotta do agile, we gotta do agile. What does that mean? Well, that means I have a ops person in my team, right? And that means we can deploy faster and we can deploy independently, and all these new features that are coming along are coming to us faster, so we can start to deploy faster. But then containers and Kubernetes and whatnot came around, and what did we find out as Java developers enthusiasts? It kind of sucks, doesn't it? Right? When containers first came around, you know, all those trade-offs that we made when Java was first invented about having a highly dynamic and, you know, late binding and all that kind of stuff really made it really slow. It took up a lot of memory compared to other things like Go or Python or Node, or, you know, pick these other languages that all the cool kids coming out of college are learning today. Right? You tell a recent college grad, oh, you should do Java. Like, what? It's like what my dad was doing. I have one of those, so yeah, I get that all the time. So if you think about what we're doing today and how we're building applications today and the challenges we have today, we don't want to lose the investment on Java because it is what it is. I mean, organizations are not going to just drop it, move on to other things. The expertise in the industry, there's tons of people that know it, that, you know, it's their bread and butter. But, you know, really where Quarkus came from, it's not like, and I'm going to say we a lot. We is not inclusive of me. We, the industry, said, well, hey, let's just whip up another Java framework out there because there isn't enough of them out there, right? We really wanted to think about, well, what are the challenges for today? What pain points do developers have today that we can solve within the ecosystem without having to have these developers learn a whole bunch of new stuff? And without having to have all this baggage from the last 20 years with it that we have to retrofit and bolt on and make backwards compatible and all that stuff. And that's really where Quarkus came from. And that was kind of the thought process behind it. And I don't know if you realize it, this was like in 2019. So, you know, Quarkus has been doing this for a few years now at this point. So if we talk about Java and some of the trade-offs about it, you know, Java has this, you know, there's a whole bunch of stuff that happens in the first couple seconds you start your application, but there's also this warm-up period that happens within your applications. The just-in-time compiler within the JVM is super, super smart about what it does. It can optimize your bytecode based on, you know, your hot code paths and what's going on. I'm totally not a JVM expert, so if you're like, I'm gonna take what Simon Ritter did from Azul Systems in his talk, like that he spent 15 minutes on, and I'm gonna shrink it into like a minute and a half. So I'll post these slides, and if you're interested, you can just Google DevOps Belgium Simon Ritter and find this talk that he did if you're interested in it. But what he basically says is the faster your application can get warm And what that means is very dependent on what your application does. It could be anywhere from a few minutes to a few hours, depending on load and whatnot. But the faster you can get there, the faster you can process whatever it is your application is doing, and the faster you can get to whatever your max SLA is. So like in a Kubernetes environment, we found sometimes where if the load starts to spike and your application comes up, but it really takes time to warm before it can get to max SLA, Kubernetes will do what? It'll say, oh, I still can't handle this load. Let me spin another. Let me spin another. Let me spin another. Let me spin it. You see what that, and by the time that like N-1 spins up, the load is gone and it comes up and says, I got nothing to do. Let me go away. Right? We call that thrashing. So what we wanted to do is come up with a runtime that can kind of solve this problem where we can get super fast warm-up time. So, and essentially hand the JVM a bunch of stuff that has already been pre-optimized so that you get the benefit, not just on the JVM, not just in native image, but on the JVM as well. One thing I kind of talk about, like native image is like this thing that's like this new shiny toy that's flying through the sky that everybody's like, oh, I want to do native image. I want to do native image. I kind of think of it as like Kafka from 5 years ago. Everybody's like, oh, I got to do Kafka. I got to do Kafka. Well, why do you want to do Kafka? Because I want to do Kafka. Everybody's doing Kafka. Well, what's your use case? It doesn't matter. I just want to do Kafka. Well, I kind of see the same thing with native image. Everybody's chasing it because they think it's super fast and super light and super small, which it is, but it's not necessarily the best use case for every problem. Right, there's other challenges and trade-offs, which I'll talk about in a little bit, but I'd venture to guess probably for 80% of use cases, running your applications on the JVM will yield you better overall performance and throughput. And so if we look at what a typical framework does, and I promise I'm going to get to code in about 5 minutes here. I'm going to spend the rest of the time looking at some code. But if you look at how a typical Java framework starts, you've got this clear separation between build and runtime. And at build time is pretty much compile, create bytecode, create your jar file, and throw it in Nexus, Artifactory, whatever you're using. And then at runtime, Java-jar, all this runtime stuff, class path scanning, and whatnot happens. I know with Spring Boot 3, they've done some stuff. Anybody like write custom Spring Boot starters and like really understands how auto configuration and stuff works? All right, then I won't bore you with all the details since nobody. But essentially, what they do under the covers, Spring is very highly based on reflection and runtime metaprocessing. They've changed to do some kind of code generation at build time so that they have to do less of it at runtime. But it's not the same because it's not doing like just-in-time compile or warm up and whatnot. It's just kind of generating some source code that gets compiled as bytecode, and then all this other runtime startup stuff still kind of happens. But if you think about it, if you're going to run your applications in containers and how are you going to scale those applications? You're just going to start multiple instances of it, right? And each instance is the same as every other instance. So why would you want to pay the penalty for a lot of that stuff if it could be fixed at build time? Totally not saying that, hey, I need to bake in my database usernames and passwords and URLs at build time. That's not what I'm talking about. I'm talking about like if I'm doing bean injection, I've got this bean and this bean, why can't I do that bean injection and generate just-in-time compiler code at build time so that at runtime I don't have all these dynamic proxies in place that have to get resolved and done. Stuff like that that's going to help boost the performance of your application, even on the JVM. And kind of a side effect of that, and I don't mean to downplay it, but like really the fact that I can compile Quarkus in native image is like a side effect of its design in the first place, right? It just kind of lends itself to being able to do all this build time optimization and be able to generate a native image, which something like Spring, like in Spring 3 and the new native stuff, they've had to like bolt on and retrofit and do it in a backwards compatible way. Anybody been doing Spring since like Spring 2, Spring 2.5, Spring 3? So I could probably write a Spring MVC controller class, like using like model and view and all those things that I did way back then, and it would still probably work. Is it the best way to do it? Probably not, but it might. I haven't tried it, so don't take my word that it will, but it would probably still work today. Anybody doing, like, with show of hands, like blocking versus reactive, WebFlux versus MVC? Anybody doing WebFlux? A couple of people? How come you're not doing it? Usually I see about a 50-50 split, so give me some reasons why you're not doing WebFlux or not doing reactive. Is it hard? Reactive programming is hard. When do you have to make the choice of how you're going to do it? When you create your GitHub repo, right? Like before you've written a line of code, you need to decide, am I going to do reactive, am I going to do block? I don't even know what problem I'm solving, but yeah, I have to make that decision. But Quarkus, I don't really care about it. At the end of, talking about technology that's circular, those of you who have done Swing programming, what was the architecture behind Swing? Single thread event loop that anytime you wanted to interact with the UI, you had to be on that thread, and then you had anytime you wanted to do work, you had to take it off that thread and do it on a background thread and then put it back. Sound familiar to like, hey, let's do this event loop thing. This is like the best thing since sliced butter. Well, we were doing that like 20 years ago, like in thick desktop client applications. But the point is, we can still have an architecture under the covers that behaves like that, but let the framework take care of, hey, I want to do reactive, I want to do blocking, I want to do mix and match. Like I want to have one JAX-RS method that's completely reactive and another one that's completely blocking in the same class, and Quarkus doesn't care. And you don't have to tell it what to do, it just kind of knows. So freeing you from having to make those decisions until really they need to be made and you know what problem you're trying to solve. But really something unique to Quarkus, and I'm not going to demonstrate it enough here, is the developer productivity, the whole inner loop cycle. I write some code, I run Maven compile, I run Maven verify, I fire it up in my browser or whatever, I send some messages to it, verify that it works, and then I kind of rinse and repeat until I'm ready to check code in. Well, what if anybody do Node.js development, like with the live coding? Anybody played with it a little bit? So what if I could just make a code change, any tests that I have that are affected by that code change get run in the background immediately, tell me if my test fails or passes, and I don't have to recompile anything, I can just go back and interact with my app, and I haven't stopped anything, I haven't had to recompile anything. This whole like continuous testing loop. What if my application needs a database or a Kafka broker or OpenID Connect authorization server? I have what Quarkus calls an extension on my class path. Rather than just configure it, Quarkus will just spin up a container for me so that I can use it while I'm doing that inner loop development. It's like I don't have to worry about, let me go find a Postgres image and go to my properties file and put it on 5.4.3. Oh, but I didn't expose the port outside the Docker network, so now I have to go expose. I don't have to do any of that stuff. It just happens. Quarkus will just spin them up and connect my application to it. In dev mode, when I go and Java-jar my application, I gotta connect it to stuff. But at the end of the day, we're still talking about Java, right? All the technologies you have people using Hibernate, JPA, a lot of these specs that are out there, Flyaway, Liquibase, anybody using technologies like this, Prometheus, Kafka, Cassandra, all these different technologies just work. And so the typical question I get is, what about the library that you don't have an extension for? And the typical example is Lombok. People use Lombok in here? Nobody uses Lombok, thank God. Lombok and me have a very hate-hate relationship, and we can have, at the party afterwards, I can have a conversation about why I hate it and why I think nobody should ever use it. But that being said, things like that, if you want to use them in your application, sure, include it. In JVM mode, you're probably good. The question is, what does that library do? Does that library do large amounts of metaprocessing? Does it do reflection? And if so, you're going to have to do some stuff in native image to get it to work. And that's not just with Quarkus. That Spring Native, Micronaut, all those different frameworks and technologies you're going to have to do that with. All right, any questions? That's my 15-minute intro. We're going to get in and look at some code here. All right. And I did a presentation earlier, and all my keyboard shortcuts stopped working for God knows whatever reason. IntelliJ did an update, and some plugin did an update, and it killed all my keyboard shortcuts. So those in the back, is that font size okay? Yeah. Because for some reason, when I near the desktop, it squishes my screen down here, so I can only see 3 lines of code on my screen up here. So I'm going to try and do it as best as I can. So I talked about that I had written a book about Spring for Quarkus, and there's a whole GitHub repo that backs that book with tons of examples, and so I'm going to use one of the examples from there. So I've got a Spring Data JPA. Everybody familiar with Spring Data JPA and how it works and what it does? So I've got an application. I've got a pretty simple domain model. I'm using Spring Boot 3. So all the JavaX.persistence has been moved into the Jakarta namespace. I've got an entity class with some fields. Oops. I've got a Spring Data JPA repository class with an extra method on it. I've got a Spring MVC controller class. I don't know why it thinks I've modified the class, but I've got a Spring MVC controller class, just a couple get methods and a post, pretty simple. I've got some properties. So my application talks to a Postgres database where it's going to store things. And in development mode, I have Hibernate set to auto-create my schema and populate data and all that good stuff, so that I don't have to worry about that. We all do that in production all the time, right? You let Hibernate control everything, right? Awesome. I've got a data SQL, and then I've got a bunch of tests. So those who know me know I write lots of tests, and I happen to write lots of tests. But anybody use test containers at all? A couple hands. So does anybody not know what test containers is? So everybody at least knows what test containers is. So I use test containers when I run my tests. When I run Maven Verify, it'll start up a Postgres database for me automatically and use that. And then I have some tests. I have some mock MVC tests that test the controller layer, and then I have tests for the repository layer. So pretty self-explanatory. So let's run this. So I'm going to start up a database, and I'm going to take some measurements as I go along, and I'm just going to do some recording in the README. So people often will measure like startup performance by kind of like the self-reported startup time of the framework. You know, when you start a Spring Boot app, it says started in X seconds, you know, JVM was active for whatever. That's okay. The metric I prefer is time to first request, right? How fast can the application start up and be ready to actually service a request to it? So I have and generally when you're doing benchmarking, you want to do like multiple iterations and take averages and all that kind of stuff. So I'm gonna do that. So I have a script here called first request java-jar, and I'm running Java 17 because you have to with Spring Boot 3. And I'm just gonna do 5 iterations. All right, so I have a script that's gonna, for every iteration, it's gonna capture time to first request and RSS, but RSS is the resident set size, so how much memory is that application using both on and off of heap? And it's gonna compute that and it's gonna give me an average. So right here, I'm just gonna start doing that. So Spring time to first request, 3.034 seconds, and average RSS is 354.1 megabytes. All right, and so now what I'm going to do is I'm going to run the application because I want to interact with it a little bit. The other metric I like to capture is after I interact with the application a bunch of times, how has the memory RSS changed? Like has it added a ton of memory usage to the application over time? Target, so let's run it. You're only gonna have to see me type it once because then I've scripted it every other time. So I'm gonna use the HTTP IE, and I'm gonna say 8080 fruits. What did I do? Oops, not HTTP IE, HTTP. So I got a couple of fruits here. If I ask for an apple, I got an apple. If I ask for, say, something that's not there, like a pineapple, I get a 404. 404 is always the right answer, right, if something doesn't exist? Or is it 204? You want to have that debate another time? Meet me outside, and I can explain to you why 404 is the right answer. And so it goes back and forth between, like, are you a REST purist, or are you a REST someone who kind of practices REST, and it depends. But the purist side, I tend to fall more on the purist side. 404 is the right answer. So now what I'm going to do is I have a JSON file, so I'm just going to post a new fruit to it, and then I'm going to come back in and say, okay, give me my fruits and give me my pineapple again, and then I'm going to compute RSS again. And so this is 365,568 into 1024, so 357. So I'll call it RSS after use, 357. Does that sound about, those do a lot of Spring programs, does that sound like about right for Spring application? Nothing like, oh my God, that's way too long, or oh my God, that's way too big or way too small. Pretty average, right? So now let's take this a step further. Native image, like I said, is this shiny widget that's flying through outer space. Let's compile this to a native binary. So clean. And I don't need to run any of my tests because we don't care about tests, right? Nobody Nobody cares about tests. That's what you always do as a developer. Like, I don't have time to write tests. I don't have time to execute my tests. I'm just going to skip them. Right, so this is going to take, so I'm running, I'm not doing any containers. I'm just doing, like, I have GraalVM actually installed on my laptop. And the Java 17, I think it's Graal 22.3, yeah, 22.3.1. I am running a Mac M1, so this process takes a whole lot less time than when I had my Intel Mac. So one thing while this is going that I tell people is, like, regardless of what framework you're using, if you're going to do native, the build process for building native images takes time and memory, right? Like gigs of heap size to build a native image and minutes of build time, which is very different than building a jar. So if you're doing CI/CD, do you really want to build a native image for every single build? And if you're using cloud, like, because when you pay for cloud instance types, it's not linear, like based on how much memory your instance types have, it's like exponential. So if you've got 100 applications and you're doing 5 check-ins a day, that's 500 builds a day. Do you really want to build a native image for all 500 of those? It's kind of like an operational thing that you want to think about, regardless of Spring, Quarkus, Micronaut, any of these frameworks that are doing that. It's kind of something you want to take into consideration. Plus, with native image, it's no longer a Java app. So if you're doing agent-based monitoring, not going to work in native image, right? So you need to think about other things like monitoring and whatnot. And it's certainly, building native images is certainly not a developer joy. It does not bring you joy as a developer to build native images, because as you can see, I'm having to fill this 2 minutes of time with other stuff so that it's not just awkward and dead silence. All right. Huh? All right, so 1 minute and 55 seconds. Let's see, native. Build time. 1 minute, 55 seconds. We're gonna track the build RSS. How much memory did that build process take? And GraalVM will hand it to us nicely, 8.31 gigs. Wow, yep. And what's the binary, the size of the binary? It tells us 130.33. 33 megabytes, right? So now let's do those kind of same tests. So I'm stopping and starting my Postgres database before each time, because Hibernate is going to create the schema and populate, and I don't want it to kind of skew the results. I want it to actually do that each time. So I'm starting and stopping. And now let's run my script again. We'll do it 5 times. Boom, 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 boom. It's a whole lot faster, right? So time to first request, 0.388 seconds. The RSS, 132.7. And then RSS after use. So let's start this puppy up. Come on. And then those same HTTP requests I have in a script, so you don't have to watch me type it each and every time. We'll script it, it'll run all those same requests again. And then if I compute RSS again, 140, 800 into 1024, call it 137.5. All right, now we'll stop this and stop my database. Oops, I closed my window by accident. So what do we got here? So on the JVM, so we've shrunk our time to first request by a power of 10, roughly. You know, I'm not using absolute numbers. We've shrunk our RSS in half, right? So that's certainly much better. So people always tell me, well, hey, if I want to play with Quarkus, I've got the Spring app, what's the best way to do it? And I'm going to completely contradict myself, because I'm going to do what I tell everybody not to do. The wrong answer would be, this is my POM file, these are all my Spring Boot starters, what are the Quarkus equivalents? Totally not the right way to go about it, but that's exactly what I'm going to do here, just because. The right way to do it would be, well, what does my app do? Am I doing REST? Am I making REST calls? Am I making REST calls out? Am I doing SOAP? Am I talking to a database? Am I doing Kafka? Am I doing messaging, OpenID Connect? What am I doing? And then go look at the Quarkus guides and figure out, well, how do I do that in Quarkus? But luckily, For some Spring stuff, Quarkus actually has adapter extension. So a Quarkus extension is kind of similar to a Spring Boot starter, except a Quarkus extension is broken into two parts. One part is how do we optimize what's going to happen at build time so that the runtime libraries can kind of take what the build process did, hand it on a silver platter, and then use it. So a lot of the dependencies, like if you were to look at a Maven transitive dependency, there's a ton. A lot of them don't even make it into the final artifact because they're used at build time and only at build time and then thrown away. So luckily, let me open my palm here. So let's do some surgery. So I'm going to get rid of a whole bunch of stuff. So I'm going to get rid of the plugin stuff. I'm going to get rid of the dependency management stuff. And I'm going to get rid of the properties. And I'm going to get rid of the parent POM. So with Spring Boot, you can either have parent POMs or you can do the dependency management build materials. With Quarkus, there's no parent. It's always done through dependency management. So I'm going to throw in here some properties. I'm going to use Quarkus 3, which, yes, I have the t-shirt that says I helped build it, but it hasn't actually been released yet. So it'll be coming out in a couple of weeks. Going to add in the dependency management stuff, so the BOM, the build materials for Quarkus, and then let's look at some of these dependencies. So I'm going to try and do this with as little invasiveness into my application as possible. I'm not going to change a single line of code. I'll have to change some of my tests, but I'm not going to touch a single line of my code. So I'm going to say Quarkus, and I'm going to copy that because I'm going to paste it a whole bunch of times. So this is Spring Boot starter data JPA. This will be Quarkus, Quarkus Spring data JPA. Then I've got Spring Boot starter web. Change that. Quarkus Spring web. And then I'm going to add, so under the covers, Quarkus has two different implementations for JAX-RS, which is the RESTful layer for doing RESTful applications. Anybody know REST-easy or heard of REST-easy before? It's the JAX-RS implementation that's in JBoss EAP and whatnot. So you can use that, or you can use what we call REST-easy reactive, which starts to scare people because they're like, I thought you said I didn't have to make a choice about reactive or blocking before I wrote a line of code. It just means that it's more tightly coupled to the underlying Vertex infrastructure, which is what Quarkus sits on top of. So if anybody knows what Vertex is, Quarkus kind of is a layer that sits on top of the Vertex runtime, and the REST-easy reactive implementation of JAX-RS is much, much tighter integrated, and it gives a whole lot better throughput and performance and whatnot. So it's actually the default. If you go to the starter and to build a new application from scratch, that's kind of what you'll get by default. But we still have to consciously make that choice here. REST-easy Reaction, we're going to use Jackson. You could use Jackson or JSONB. Spring likes Jackson, so I'm just going to use Jackson so I don't have to make any other changes. The other dependency I'm going to add is I'm using YAML. I like YAML for configuration rather than properties. I just I like the structure of it. So I need to bring in an extension for YAML, Quarkus config YAML. I've got the Spring Boot starter validation for doing Hibernate validate, bringing Hibernate validator to validate my entities before they get persisted. So I'm going to swap that for Quarkus Hibernate validator. And then I've got the Spring Boot starter actuator, which does a lot of stuff. I mean, we're really using it for the liveness and readiness probes and startup probes and all that kind of stuff. So I'm going to switch the actuator for what's called SmallRye Health. So SmallRye, if you're not familiar, is an implementation of a lot of the Eclipse microprofile specs, which Quarkus is based on. So for health checks and config properties and all that kind of stuff, the microprofile spec has all that, and SmallRye is the implementation that Quarkus uses. So people might say, oh, you got a Postgres driver, why are you switching that to a Quarkus extension? Because, like I said before, there's a whole bunch of stuff that happens at build time to optimize, so even for JDBC drivers, to make them more efficient and do all the class loading and class introspection to make it ready for the just-in-time compiler. So all that happens at build time, which is why we bring an extension instead of the raw JDBC driver. And then we start talking about tests. So instead of, I didn't remember what I copied and pasted. Instead of Spring Boot starter test, we're going to bring in Quarkus J Unit 5. So just like Spring, Quarkus uses JUnit 5, Mockito, all those same testing tools and libraries that you're probably already using. I don't need any of these test containers dependencies. They can go bye-bye. People use AssertJ as a Java assertions library. People are familiar with that. So in Spring, the Spring Boot bill of materials manages the version of that. In Quarkus, it does not. So you have to tell it what the version is. Then the only other dependencies I need to add here are using Mockito. So I need to add the Quarkus JUnit 5 Mockito in the test scope. I've made that mistake before. And then I have to add, so Rest Assured, everybody familiar with Rest Assured? So Rest Assured is a REST testing framework. You can use it in Spring. People usually use mock MVC, but you can certainly use it in Spring. It's not specific to Quarkus. That's not the right artifact. I don't want JSON path, I want Rest Assured. Rest Assured in the test scope. Test. Cool. So now what am I going to do? I'm going to come back to my command line and I'm going to run maven clean Quarkus dev. So Quarkus ships with this dev mode, which gives you all of that, like I said, the live reload, continuous testing, all that kind of stuff. So I still haven't touched a line of code. And of course it fails. Why does it fail? Oh, because I haven't added any plugins yet. I didn't finish my POM. That's probably a good reason to fail. So I add in like the Quarkus Maven plugin, the compiler plugin, the Surefire plugin. Anybody like Gradle more than Maven? I am like so a Gradle person and not a Maven person, but say lovey, so much less stuff. So let's try this again. So it's going to start up and it fails again. Why? Because I've got some of these other classes, like the Spring Boot application class. What purpose does this class serve? So take a step. So I've been doing software development for like 20-something years. When I was like fresh out of college, I'd like write some code and write some tests, and you go to your tech lead or do a review. It's like, look at all this beautiful code that I wrote. It's so good. It's so well tested. Fast forward 20 years, and what are you proud of now? Look at all this code I deleted. We don't have to maintain this code. It's so much more maintainable because I don't have all these tests. I don't have all this code. It's like evolution, right? So now I get to delete code. I can come in, I can say, oh, I don't need this. And because I deleted the code, I don't need the tests. Everybody always writes tests, lots of tests, and you always write them before you write your code, right? Just nod your head and say yes. And I also don't need, because I've got this separate configuration for test time, I don't need that either. So I can get rid of that, and I can even go into my main application, and I can get rid of everything in there, because I don't need it. So now let's see what happens. So there's some errors, but it looks like the application is starting and the application is up. What are these errors here? So it looks like some test, so it hasn't been able to compile the test, which is fine, we'll fix that in a second. But my application is up. And if you look at some of these logs here, it says this dev services for the default Postgres started and setting Hibernate ORM generation to drop create. If I go to another window here and I do like a Docker PS, you can see it's running a Postgres instance because it saw, hey, you got a Postgres driver, you didn't tell me what to connect to. You probably want a database, let me go grab one for you. And it kind of picked one. I could customize it if I wanted to. It picked Postgres 14. Same thing with like Kafka or Keycloak or OpenID Connect or Redis or Infinispan, any of these other types of things that I might use, it'll do the same thing for you. And what's kind of cool, if you're working on more than one application that use like a message broker or Kafka or something, and you run them both locally, it'll only stand up one broker and it'll connect all your applications to them without you having to do any kind of configuration whatsoever. And so now what I can do is, see, it sees this little thing, tests pods. Press R to resume testing. So that's what I'm going to push. And it says it can't find any tests. So that kind of makes sense because they didn't compile, right? So let's go fix that. So I can come in here. We'll come to the controller tests after. Let's start at the bottom and come up. So we've got this at Spring Boot test. I'm going to change to at Quarkus test. Does anybody know I'm sure people know what transactional means, right? But what does it mean when you apply it to a test method or a test class in Spring? What does Spring do? Or Spring Data JPA specifically? It'll run all of your tests in an isolated database transaction and roll the transaction back when you're done, right? So no more like, everybody's like, I run all my tests and I use H2, and then when I go to this environment, I use MySQL or Postgres, and then when I go to production, I use SQL Server or Oracle or whatever, right? These containers are so fast and Quarkus is so fast, forget about H2, forget about in-memory. Do you know how many times like I've done something and my tests all pass and I deploy it in a real environment with like a real Postgres and it blows up because the SQL dialect is wrong, or I've used like a function in my SQL statement that doesn't work in that version of Postgres? Just test with the real damn database, right? Like, why do this in-memory mocking thing? Just use the real thing. It gives you a whole lot more confidence that what you're actually writing is going to deploy to an environment that is actually real and has real data for you. So I'm going to change this transactional, because in Quarkus we have test transaction. And I'm going to save, and you see it kind of in the background. It's still saying, it's saying that my data I should have data. And the reason why is because if I go and I run now my HTTP and I ask for some fruits, I don't have anything. Why do you think that is? Because in Spring Boot, the file is called data.sql, right? And in Quarkus, it's called import.sql. So I can say refactor, rename. Make the change, reload, and now I've got data. And now if I come back to my other tab, my test is green. My test, this test class now passes, the test runs, and it runs successfully. Oops, not that one, this one. And all I did was touch a few annotations. I haven't done anything to it. So now let's go to, this one's a little more complicated because this uses mock MVC and whatnot. So let's do some surgery here. So this will be at Quarkus test. I don't need this mock MVC thing anymore. So essentially now I need to convert from mock MVC to rest assured is essentially what I'm doing. I'm only going to do it for one method because it's the same thing over and over and over again. So folks use Mockito to do like mocking and whatnot. So instead of at mock bean, I'm going to say at inject mock. Now I get my mock, and then what I need to do, and then I hate that it makes you throw, all your methods throw exception. That's just kind of ugly and dirty. So I'm going to say rest assured get, then status code 200, content type JSON, and then I'm going to do just some global search and replace here. So instead of .and expect, I'm going to say .body. And then instead of this, say, oops, you can tell I've done this a few times before. And then this comes from the Hamcrest Matchers project. So now if I save, it still thinks that there's errors because I haven't converted everything yet. I can remove the exception. And I can do similar things. I'm just going to get rid of that completely. What happened here? My method code. Then rest assured. And my IDE, I don't know why, for whatever reason, it will not static import rest assured. I don't know why I spent countless hours and I finally gave up, because usually it's so much cleaner not to have rest assured dot. I have no idea. If anybody wants to come look at my IDE later and help me out, I really have no idea why it does that. It's recent too, because it's just updated to 2023.1, and then that started happening. All right, so now I'm going to copy paste that in. Similar thing here. Rest assured dot, and then except instead of 200, it's 404. Oops. And then the last part, you can see like the testing is like picking it up every time I type something. It's doing stuff in the background. And the last one is the post, which is a little bit more involved, but not terrible. I can say, huh? Yeah, well, if you ask just in general, if you ask for something that doesn't exist, it gives you a 404, just in general. So this test was doing, well, in particular, I'm mocking the repository. So I'm basically saying when I ask for an apple, then give me nothing in the mock. And so then when I make the request and I expect that I get a 404, which translates optional empty to 404 in the REST layer. So I can say given body, I'm going to take the same body here, copy paste with content type JSON, and then I'm going to say dot post to fruits, then, and then I'm going to go back and copy paste this part of it from the previous test, throw it in here, save, and now all my tests should be green. All my tests are green. Everything runs. I've not touched a single line of code in my application, so I still have my domain, I've still got my repository, I've still got my Spring MVC controller, I haven't touched a line of code. So now the question, like, was it worth it? Yeah.
So maybe it's questions for you. I'm not much familiar with the Quarkus. When you moved it to the Quarkus application, is it became a non-blocking thread application, or it's still like blocking?
So the question is, when you move to the Quarkus, does it become blocking or non-blocking? So Quarkus, so the extensions that kind of tell Quarkus to understand Spring, that is basically like a compile time adaptation to JAX-RS, and it takes the Spring Data JPA and it adapts it to Hibernate, like raw Hibernate at build time. So like if I would actually go look at the bytecode, you'd see like JAX-RS code and Hibernate code. There's no Spring in my application at runtime at all. So while it's good for like doing quick things or POCs or even some production applications, it's not meant to mirror the entire Spring ecosystem of every library and every API. But specific to your question, Quarkus is very smart about inspecting your methods at compile time, at build time. And so if I'm returning, like in this case, like a list, this is going to be a blocking method. It's going to take the execution of this method, move it off to a worker thread, execute it. When it's done, bring it back to the event loop thread and send it back.
So to make it non-blocking, you still need to do some code adjustment.
So if I knew this method was non-blocking, I could say non-blocking, and now Quarkus will keep it on the event loop. If I was using reactive APIs and I was returning reactive APIs, Quarkus would just do it automatically for me, and I wouldn't have to know, or I wouldn't have to tell Quarkus. Like if Quarkus uses the Mutiny reactive library under the covers, but you could translate it to Reactor or whatever, RxJava. So in that case, if I was returning like a Flux or whatever, it would keep it non-blocking without me having to tell it. It would just do it. So now that we've built it, let's actually, was it actually worth it? Package, skip tests. And let's rerun our test scenarios here, because that's the whole point of this talk. So what if you could tell, actually I'll ask that question in a second when I have dead space, when it's doing GraalVM native image, I can ask that question. So I'm gonna run Docker run, I'm gonna run my database, oops. Huh. All right, I don't know why it was still running. All right, so now if I run my test, first request, oops, java-jar, I'm going to run it, do the same test 5 times. Oops, no data sources are defined. So what did I do? In my application, so in dev mode, it would spin up this nice Postgres container and bound my app to it, great. But when I java-jar, I need a Postgres container somewhere, right? I have to tell it where it is. So I can go into my configuration and I can basically, similar to what we had with Spring, tell it where my database is. And now I got to compile it again. Takes a second. So now I do my first request. Or 5. So here's Quarkus. Time to first request. 1.407 seconds, and RSS was 244.9 MB. How does that compare? So we're well under half the amount of startup time, and at least startup RSS, we're well under 100 megs smaller. Haven't touched a line of code. So now if I run the application, and then I send some load at it, I have a couple requests, and then I do my RSS, 258.176 into 1024 is 252.1. What did I say, 252.1? Then I said 252.1 is well smaller than 357. So now let's do native. Stop my app. Yep, I'm going to time the build time now. So this should be, in my tip, about half the amount of time that it takes, and it probably uses like a gig or two less of heap space. Same Graal VM instance. So I was going to fill this time with something, and I forget what I was going to say. What was I going to say? Anybody? Erin can tell me what I was going to say. She's paying attention.
What is the native artifact as Docker image?
I'm sorry?
When you build the native Docker image?
I'm not doing any container images. I'm doing flat. I have Graal VM here, and I'm building a machine binary for this on my machine. I don't have any container images. No, you could. If you didn't have, because a lot of people can't run Docker on their work laptops, so you could use like Jib or something, and it could build a container and push it to a registry without actually running the Docker runtime, and it could use and build your native images in a container, if that's what you want to do.
When running in dev mode, is it possible to customize those the images that it's setting up for you?
Yep. So the question is, when you run in dev mode, can you customize the images? So like if I want to use Confluent Kafka instead of Red Panda or StreamZ or whatever, yeah. And if I want a specific version of like Postgres, I could tell it that through configuration. The only time you can turn it off completely and completely configure your app if that's what you want to do, or you could tell it, use this for one service but use that for another service. It's all configurable. All right, so native build time 1 minute 8 seconds. So that was close to a minute shorter. So build RSS. 6.89 gigabytes compared to 8.3, so gig and a half smaller. So the binary size 73.25 compared to 130, so about half the size for the same code. And now the ultimate test here. Start my database. If I could type right. And not 10 times, 5 times. Boom, 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 boom. I don't know why it pops these things up. So time to first request, 0.204 seconds, and RSS. This is what? This is Quarkus. 61.2. So 0.204 instead of 0.3, so a little less than half. RSS, so 61, so well under half the size. So I guess here's the question I was going to ask. Given all the applications you're running today, what if you could tell your ops team you can still run those but cut your costs in half? What do you think they'd say? You could get rid of half of the machines that you're currently operating today and run the same amount of stuff. You think they'd be happy about that? They would believe you. They wouldn't believe you. So just to kind of wrap up, they're just about out of time here. So I showed it. This is a completely uncontrolled environment, right? Yet someone could come and say, oh, but that's on your laptop. It's not a controlled environment. By all means, I would be the first one to say it's a completely uncontrolled environment, but it's something I've been doing for a long time, and I actually have been tracking Spring 2, Spring 3, Quarkus 2, Quarkus 3 for like 3 years now. I have like this really long spreadsheet that has the stuff, and the diff is only gone like this, because if you were to compare Spring 3 with Spring 2, Spring 3 is bigger, slower, takes more memory than Spring 2 does. But I'm not the only person who's found it. There's a Tech and Power benchmark up there. So looking like purely reactive, like Quarkus reactive with like reactive databases and whatnot, will blow anything away. Then you've got like the Quarkus blocking, and you've even got Helidon that sits there on top of Spring Webflux in terms of benchmarking performance. But we also do at Red Hat, I work for Red Hat, in our lab environment, we'll take Quarkus and Spring. Whenever we do a new version of our productized version of Quarkus that we call Red Hat Build of Quarkus, we'll look at whatever the community Spring is at that point in time. So these numbers are run about 3 weeks ago. And we run them in a lab environment. We run it continuously. So on an 8-core, 12 gigs of RAM, Graal VM Java 11, we compare time to first request build times. What's really interesting is throughput, and the numbers here on my screen are really, really small, and I can't read them, so I'm just going to kind of point to them. But looking at throughput, like how much throughput could you send to that application, a single instance of it, before it fell over on its face and like completely crashed? And you can see like in the JVM mode, Quarkus, you can get over 2.5 times the throughput on the JVM. The other metric that's kind of interesting where I've kind of highlighted is what we call max throughput density. So at that point in time, when it's given it its all, and if you give it one more request, it's going to fall over on its face, how many requests per second could it handle per megabyte of memory that it's consuming? And Quarkus on the JVM is like well over 3 times 3 times smaller at max throughput, as well as on native, you can see it's almost 4 times. But the really interesting correlation is Quarkus on the JVM is 2 times more dense than Spring in native. So kind of let that sink in for a second. And these are real numbers, like produced in a lab, reproducible in a lab. And when I first saw this, I was like, there's got to be an error. So I reran the benchmark, which each time this runs, it's like hours. So a couple days later, I came back and looked at it all, and the numbers were a little bit different, but the percentages and the differences were consistent. Another thing that people don't really think about is, well, what's the cost of running? And I kind of alluded to it. What if you could save half the amount of money in servers that you're running today? But what's the carbon footprint? And how do you measure carbon footprint and carbon emissions of servers and my applications? We actually did a study of it. One of my partners that I spoke with earlier, Holly Cummins, did a study of this. And what they found is they could run the same application, well, not exactly the same, but the same functionality, run it continuously for 20 days, funnel it at 50% load, which was about 800 requests per second continuously. We could get the same throughput on a T2 micro with Quarkus that you could on a T2 medium for Spring. So we could shrink the instance type, and they found, and I don't know anything about measuring carbon footprint. That's like a whole separate science. If you want to read about how to measure carbon footprint in electricity and whatnot, there's a couple links there. You go read the whole study. But essentially, over that test period, we found that the Quarkus version put out 3 times less carbon footprint than the Spring version of it. So if you want to be a good corporate citizen and save money and save trees and all that kind of stuff, just kind of switching your Java framework can get you pretty far away, or pretty close to it. And with that, don't forget, I'm going to go out and do a book signing. Like I said, I've only got limited copies of it. That's about it. Thank you very much for coming. Sure.